Good morning, everybody. We are back for our second day of online learning. We are going to be continuing with 4.A functions, and our learning target, which we'll start with today, is to find key features of exponential functions and graph exponential functions. So yesterday we talked about expressions which don't have an equal sign, one variable equations, which we are able to solve for x, and functions. So remember, functions have an input and an output, and an exponential function is in the form f of x equals b to the x power. So we're going to be graphing exponential functions today. So the first function we are graphing is f of x equals 2 to the x power. And remember, if we don't know what a graph looks like, or we aren't familiar with the graph, we can always graph a function by making an input-output table, which is what we're going to do here. So I'm going to make an input-output table, so x and f of x, for this function, f of x equals 2 to the x power. So remember, you can pick any x values you want. However, we are going to choose -2, -1, 0, 1, and 2. That way we have some positives, some negatives, and 0. That should give us a good idea of what our graph looks like. So then if those are my x values or my inputs, to find my f of x values, I plug those in. So I'm going to plug in the -2 into this function, 2 to the x power. So 2 to the -2 power. Hopefully we remember from yesterday and our previous problems, if we have a negative exponent, this is a fraction. So to evaluate this, I say jump the line and switch the sign. So this is going to jump to the bottom of a fraction. We're going to have 1 over 2 to the +2 power. So jump the line and switch the sign. The 2 becomes positive. So 1 over 2 squared is 1 over 4. So when my input is -2, my output is 1/4. All right, let's plug in a -1. So 2 to the -1 power, same thing. This would be a fraction. So I'm going to jump the line and switch the sign. This is going to be 1 over 2 to the 1 power, which is 1/2, 1 over 2. If I plug in a 0, we'd have 2 to the 0 power. Remember, anything to the 0 power is just 1. When I plug in the 1, I'd have 2 to the 1 power, which is just 2. And if I plug in a 2, I'd have 2 to the 2nd power, 2 to the 2 power, which is 4. So we've got our table, so let's go ahead and plot those. So my first point, I have a coordinate point, a -2, 1/4. That means I go left 2 and then up a 4th. So if I'm going up a 4th, it's a fraction, so it's between 0 and 1. I'm just going to go up a little bit above the x-axis. The next point is -1, 1/2. So I go left 1 and up a 1/2. So between the 0 and the 1. The next point is 0, 1, right here. Then 1, 2, right 1, up 2, and 2, 4, right 2, up 4. All right, so here's the points we have. So let's think about what is happening with this graph. As we keep plugging in bigger x values, our outputs are going to keep getting bigger and bigger. So if I plug in a 3, I'd have 2 to the 3rd power, which is 8. If I plug in a 4, I'd have 2 to the 4th power, which is 16. If I plug in a 5, I'd have 2 to the 5th power, which is 32. So as we keep going towards the right, our graph keeps getting bigger and bigger or approaches infinity. Now let's think about what's happening as we go towards the left or plug in negative x values. So if I plug in, for example, a -3, 2 to the -3 power would be a fraction. I'd have 1 over 2 to the 3rd power, or 1/8. So that'd be just a really small fraction. If I plug in a -4, I'd have 2 to the -4th, or 1/16. Then I'd have 1 over 32, 1 over 64. So what's happening here is that the numbers are getting smaller and smaller, or closer and closer to 0. So that means our graph is getting closer and closer to this axis, but it's never crossing or touching, because even though if I have a negative exponent, my outputs are still always a positive number. So what's happening here is that we have a asymptote. So remember, an asymptote is a line that the graph gets closer and closer to, but doesn't actually touch. So a exponential function has a horizontal asymptote. It does not have any vertical asymptote. So the horizontal asymptote is at y equals 0. And notice that this is an increasing function. So when we talked about functions, increasing means it's going up as we go from left to right. It's increasing on its entire domain. So the function is an increasing function, which means this one is exponential growth. All right, we're going to look at another graph as well. So our next graph is f of x equals 1/2 to the x power and f of x equals 2 to the negative x power. We're going to go ahead and graph both of those on the same coordinate plane. So we're going to do the same thing. We're going to make an input-output table. So starting with this one, f of x equals 1/2 to the x. I am going to make my input-output table for x and f of x. I'm going to pick my x values. So I'm picking -2, -1, 0, 1, and 2. And like before, we're plugging these in. This is going to be a little harder to evaluate because I have a fraction to an exponent. So we'll have to try to remember how to do that. So the first one, I'm going to have 1/2 to the -2 power. So first we have to remember what to do since we have a base that is a fraction. So if I have 1/2 to the -2 power, that means I have to do both the numerator and denominator to the -2 power. So I'm going to have 1 to the -2 power over 2 to the -2 power. Now both of these are negative exponents. So both of these are going to become fractions. So that means this one that's on the top, as I say, is going to jump the line and switch the sign. So that one's going to become 1 to the +2 power on the bottom. Now this one's on the bottom. Same thing though, it's going to jump the line and switch the sign. So this is going to jump to the top, and that's going to become 2 to the +2 power on the top. So then if I simplify this, on the top, 2 squared or 2 to the second power is 4. And then on the bottom, 1 to the second power or 1 squared is 1. And so 4 over 1, we just get an output of 4. All right, let's plug in the -1. So we're going to have 1/2 to the -1 power. Same as before, I'm going to do both the numerator and denominator to the -1 power. So I'm going to have 1 to the -1 over 2 to the -1 power. And again, both have negative exponents, so they both jump the line and switch the sign. This one jumps to the bottom, and that's going to become 1 to the 1 power. This one, since it's on the bottom, jumps to the top and becomes 2 to the +1 power. And so that would just be 2 over 1, or an output of 2. All right, next let's plug in 0. Luckily that one's easier. 1/2 to the 0 power, anything to the 0 power is just 1. Then if I plug in a 1, 1/2 to the 1 power is just a half. And if I plug in a 2, 1/2 to the second power, like I did on the first numbers, I can raise each of these to the second power. So 1 to the second power over 2 to the second power, that would give us 1 on the top over 4 on the bottom. So 1/4. So let's go ahead and plot this one first. So -2, 4, that means I would go left 2 and up 4 to plot that point. -1, 2, left 2, left 1 and up 2. I have a point at 0, 1. 1, 1/2 means I go right 1 and up a half, and then 2, a fourth. So over 2 and up a fourth. So you might be able to guess what's happening on this graph if we think about what happened on our previous graph. But this time, as we're plugging in bigger x values are going to the right, my outputs are getting actually smaller. So like 1/2 to the third power would be 1/8, or 1/2 to the fourth power would be 1/16. So this time as we're going towards the right, the graph is getting, the outputs are getting closer and closer to 0. So the graph is getting closer and closer to that axis, but not actually touching. Now as we go to the left, the outputs are getting bigger and bigger like this. So here is our exponential function. And so again, this also has a horizontal asymptote where the graph is getting closer and closer to that line, but not actually touching. So this time, the horizontal asymptote is y equals 0. So it's still the same line as before. But the important thing to notice about this one is that the graph is decreasing as we go from left to right. It's going down as we go from left to right. So this would be an exponential decay function. So when our base was a fraction, we ended up with a decreasing function. Now, we also want to graph this one, f of x equals 2 to the negative x power, and see what that looks like. So I'm going to erase this work here so I have room to make another table. So I'm going to make a table for the second function, x and f of x. And I'm going to use the same x values, -2, -1, 0, 1, and 2. All right, so let's plug those in. This time we're using f of x equals 2 to the negative x power. All right, so when I plug in a -2, I'd have 2 to the negative 2 power, which would become 2 to the positive 2 power, which is 4. All right, if I plug in a -1, we'd have 2 to the negative 1 power, since it's 2 to the negative x. So that would be 2 to the positive 1 power, which is 2. We plug in a 0, we just have 2 to the negative 0 power. Since there's no such thing as negative 0, this is just 2 to the 0 power. And remember, anything to the 0 power is 1. If we plug in a 1, we'd have 2 to the negative 1 power. And remember, that is a fraction. Jump the line and switch the sign, so that'd be 1/2. And if I plug in a 2, we'd have 2 to the negative 2 power. Also a fraction. This would be 1 over 2 squared, or 1 over 4. So notice here, we actually get all of the exact same points. So these two functions are the same. They're both exponential decay. They're just written in a slightly different way.